We have seen in previous simultaneous lesson that by solving simultaneous equation, what we get, is one solution, a set of value of x and y, okay, and this is what we call as the unique solution that satisfies both the equation. Okay, so we want to find we use simultaneous equation basically to find a unique solution that satisfy both the equation, and we have seen that using elimination method. Okay, but now, okay, what we want is to interpret the result of simultaneous equation. Okay, what does the x value mean and what does the y value mean? Okay, so to understand that better, you have your homework here. Okay, it's basically just drawing the graph. Okay, so this is the same equation that we have seen before. X minus y equals to 2 and x plus 2y equals to 4. So before drawing the graph, actually that should have said draw, not sketch, because you are taking many points and you're doing it to scale. But anyways, so first things first, before you draw it, okay, because the equation y is not the subject, so what we are going to do is to make y the subject. Y is equals to x minus 2. And here, when we make y the subject, that will be 14 minus x over 2. Okay, these are basically, I've given you the guideline on how to draw the two graphs. So for the graph y equals to x minus 2, so we're going to plot from 0 to 10. Okay, that's my x-axis and that's my y-axis. So we're going to plot from 0 to 10. When x equals to 0, that's minus 2. X equals to 2, y is 0. And then the next one, y is 2, 4, 6, and 8. Okay, for the next graph, y equals to 14 minus x over 2. So if we put 0 in there, y is 7. Substitute 2, you get 6. And then 5, 4, 3, and 2. Okay, so we can plot these points. So let's plot the points for y equals to x minus 2. So y equals to x minus 2, so 0. My minus 2 is somewhere down there. But 2, 0 will be here. Okay, 4, 2. 6, 4. 8 and 6. And 10 and 8. Oops. Okay. So it's a straight line, okay, because we know that it is a linear equation, so you know that it will give you, doesn't work, okay, sorry. When you draw, make sure you use your ruler, okay? I'm using freehand. Right, so that is the graph for y equals 2, and very important here, we label the line. Okay, so I was saying just now that we are plotting points for a linear equation, so you know that you will get a straight line. Okay, the next one, 0, y is 7, 2 and 6, 4 and, where's 4? Oops, 0, 2, 4. 4 and 5, 6 and 4, 8 and 3, 10 and 2. Okay, so Okay, and that is the graph of y equals to 14 minus x over 2. Okay, so very important when you draw a graph, make sure you label your graph to tell the examiner what is it showing. Okay, so this line here, it shows all the pairs of value that satisfy y equals to x minus 2. The other line here, well, I could have drawn it with a different color, but it's okay. So now this line here, okay, it also, again, it shows or tells you all the pairs of value which satisfy this equation, y equal to 14 minus x over 2 or x plus 2y equals to 14. Okay, now observe what else that you can see on the graph other than the two lines, other than two straight lines. What else can you see? Do you see that two lines meet? Yeah. So, and remember when we solve these two equations simultaneously and we obtain the value x equals to 6 and y equals to 4. Okay, so now that tells us, or if you want to interpret the result, basically by solving two equations simultaneously, what we get is the point of intersection. Okay, this is the point, this is the idea that I want to show you. Okay, solving two equations simultaneously, not only that you get a unique solution that satisfies both equation, this unique solution is actually the point of intersection of two lines. Okay, so the method to solve for points of intersection is simultaneous equation, and you'll come across later on in our syllabus points of intersection. You will come across in coordinate geometry, I think maybe in function as well, or even differentiation as well in AMAT. So this point, okay, or the values, x value and y value that you've got using simultaneous equation is a unique solution that satisfies both equation. In other words, because the solution satisfies both equation, it means that that point is actually where the two lines meet. And when two lines meet, it has a point of intersection. Okay, so there you go. I will write that down. That is what we call as point of intersection. All right, so now you know that the method to find point of intersection is simultaneous equation. All right, guys. Yeah, and also one thing, now you also have another method to find simultaneous equation. One you have learned was elimination method. Now you know there's a second method, which is a graphical method. You can use graph to check your answers, or using graph as a method to solve simultaneous equation. There you go. Okay, because we say that simultaneous equation can be solved using elimination and substitution. We'll cover substitution in a bit, but now I've also shown you another method to solve simultaneous equation. You can use graph. Okay, and the answer or the solution is basically the point of intersection. Okay, that's all for me today not that's all for me today, but basically that is all for this part, is to interpret the result of simultaneous equation. Okay, thank you very much, guys.